Welcome again. And if you haven't watched the previous video, I recommend you to do so to understand how to use ORTools. If you have, welcome again, and let's speak about how to build a benchmark in a very simple way to be able to test our models. Good. So first of all, we need to build a function so that we can try, or actually we don't need a function, but I'm going to put this in a single cell because all of this should be actually executed together. So I'm gonna get this, and I'm also going to get this. I don't really need the last bit, or maybe I will. Let's take it. All right. So I'm gonna build a function def test performance. Usually here I would put some arguments regarding our task, our problem that we need to solve. Other than that, I'm just going to do a basic solution on this problem that we solved in the previous video. And here I'm going to put the model. Let's call it like this. It's not going to have a default because we're going to put it, so I'm going to put here model. Good. Other than that, now we need, in order to track time of execution, we need to import time. How we're going to use time? We're going to use time like, for example, start equals time dot time, right? And we're going to, after we run this, at the end of our cell, we're going to use timeout time dot time minus start. Now this would work, of course. What is the other approach is not to use the time, but use the time dot time nanoseconds, so you can get this, and then we can get again here the nanoseconds, I believe. Time dot time, not I try to call it, no, wait. So this, and again like this. Okay, so now we have this as a nanoseconds, which is kind of okay. Both ways doesn't really matter. The idea is to get the time. So how we should do this? Again, putting this on top and very simply returning this, because at the moment I really care about the execution. That's why I wasn't sure if I need this as values. Yeah, if you want, you can integrate these values and check it. Other than that, it's good to be like this. So if we are looking to test performance on approach, how to get approach, I can go to documentation of the create solver, or I can simply click on here into the create solver, shift tab, and I will see all these variables. What I'm going to do is I'm going to go with the glob, and I'm going to do it here. Basically 0. Let's see if we put time, maybe we can get something, or it's just pretty fast. Yeah, nothing much out of it. Maybe we should add some complexity to this task. Anyway, using your own problem, you should get viable time maybe. But given our problem here, we're just going to keep it like this. What are we going to do as an input here? Very simple. Again, we're going to take it our yeah, we can take it like this. All the approaches, so we can just go with okay, so with out and control, you can click here at the end and just do a multi-line like this. So I'm cutting this, I'm doing this like a new cell, getting all that. I could actually do this again. Okay, and this will be our problem dictionary or model performance. Good. Now what we're going to do is we're going to test performance for OD variable, for OD approaches. We're also going to go with the try Excel because we may not have access to all of the models, which is completely fine. So for model in test performance dot keys. So in that I'm going to go with try, then I'm going to try model pref inside, we're going to go for model is equal to test performance, the same value. Other than that, we're going to go with except, and we're going to maybe we're going to see the exception as X, and we're going to print it. What is this here? Here is not defined. I missed the comma. Function has no attribute. My mistake. It's model performance. Non-type has no. All right. Let's see what is our output out of this. Maybe actually we should do these values to be -1. So -1. All right. So we can see that for these three models, we actually these models weren't available to us. Anyway, other than that, we get this model. So for SCIP, we get these nanoseconds, which I'm not sure how much seconds it did, but it's definitely less than a second. CPSAT, on the other hand, is maybe the slowest one from this group, but that's all right, around 1 second and 1.7 seconds. And here we have also 1 second for CBC and COP. Glop and BOP seems to be the best performing models. If you are able to perform this on your data and on your problem, you should be fairly quickly find out which model is suitable for you. Thanks for watching. Like, subscribe, comment, and see you soon.